we're going to go through the starter. And this is hopefully you've already done this, and this is just review of what you've already done. But if you haven't, this is how we look at this. So the direction of opening is determined by that value A. If it's positive, it opens up. And if it's negative, if A is negative, then it opens down. And so in this case, A is positive. In fact, we're going to go ahead and list out A, B, and C because we're going to need each of those. A, B, and C. A is 2, and B is 11, and C is 5. And the direction of opening is up precisely because A is 2, and 2 is positive. All right, x-intercepts. We're going to skip that. We'll come back to it. Y-intercept is the easiest thing we get from standard form, and it's always 0, C, which in general sense, but in this case specifically, is 0, 5. So it's always that one at the end. And so, and make sure that you write it as an ordered pair because it's a point. So it's 0 in X and 5 in Y. And then our vertex. Actually, we're going to do the axis of symmetry first. Remember here that we got a whole song about this. X equals negative B over 2A. And then we plug it in. Negative B over 2A. And B is 11. And A is 2. And so what I've got then as a result then is negative 11 on the top and 2 times 2, 4 on the bottom. And you know, just do that division. Negative 11 divide by 4 is negative 2.75. And so negative 2.75. So my axis of symmetry, remember it's an equation. So you always got to put x equals, and then whatever the number is. In this case, negative 2.75. And negative 2.75 is between negative 2 and negative 3. So I'm going to count over here. 1, 2, and then not quite to 3. Right there, that negative 2.75, that's where I'm going to draw my axis of symmetry. Just a dotted line to help me remember that my parabola is symmetrical about that line. All right. So now we know part of the vertex. Negative 2.75 is the x-coordinate. And my y-coordinate, I'm going to plug it in. So this equation here, I'm going to rewrite it, but instead of f of x, I'm just going to write y because it helps me remember that's what I'm looking at. Y equals 2 times negative 2.75 squared plus 11 times negative 2.75 plus 5. And so here you can see, let's use a different color for this one. Here's x and here's x. And so what I plugged in right here, I just put a negative 2.75 there and negative 2.75 there. It is important that you remember that you've got to square that thing. So watch for that. And for this, I just put it in my calculator. So I'd go over here and I put in 2, and then my parentheses, negative 2.75, close my parentheses, and square it. Remember to square that. If you don't put the square, you won't get the wrong answer. And then put plus 11, parentheses again, negative 2.75, close the parentheses, and then plus 5. And then just hit enter. If you've done that correctly, you should get negative 10.125. And then we'll plug that in over here. So I got negative, switch the color, negative 10.125. And that's between negative 10 and negative 11, but it's going to be closer to negative 10. So I'm just going to count down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it's just going to be slightly below that. That's my vertex. And so I've graphed that. My y-intercept, I'm going to graph that next. 0, 5, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so that point is my y-intercept. Let's mark it since we've got it colored here. That's that. And then because of the whole buy one, get one free deal, I know this is 1, 2, and then 0.75 units over there. So I go over here at 0.75 units, and then 1 and 2, and this is where my other point is, right there. And so that looks about right? This distance is about the same as this distance. That should be true. Okay, so now I need my x-intercepts. And to get my x-intercepts, this is what like a large part of this whole unit was about. I'm going to get my quadratic formula. So we sing the song. You guys are listening to this video. By the way, listen up. Are you all listening? Listening? Okay, good. Everyone? Hey, you're not listening. Listen up. I'm going to be here before the end of this period. And I want to come back and see that you've done some good work. So get on it. Sing with me. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And then right below it, I put negative b plus or minus, let's put it, negative b plus or minus the square root all over 2a. And b, check, is 11. So 11. And then my discriminant. Oh, did I do this without finding the discriminant? I did. Guys, sheesh, man. I should have found the discriminant first. Let's do that first before we continue. B squared minus 4ac. That's our discriminant. And we go b squared minus 4ac. And b is, like we said, it's 11. A is 2 and c is 5. A is 2 and c is 5. So you can just plug that in your calculator and get the value. Let's go ahead and do that. So I type in 11 squared minus 4 times a, which is 2, and c, which is 5. And then I hit enter, and I get 81. Fantastic. So you can work through this by hand. You can just go through and kind of verify. 11 squared would be 121. 2 times 5 is 10, times 4 is 40, so this is 40. You take 121 minus 40, you get 81. It's that same thing. And I just verified, if you check one against the other, that's a good idea. The 81, you recall, with your discriminant, our discriminant is this. Discriminant. And you have 3 possibilities. It could be positive, it could be 0, or it could be negative. And if it's positive, you get 2 real roots. If it's 0, you get 1 real root. If it's negative, you get 2 non-real real roots. And then because in this case we know that a is positive, a is 2. This is our a. And it's positive, we know it opens up. And so the graph of this, when you have positive discriminant, would look something like this. Now, it could be further to one side or the other, but it's going to have 2 x-intercepts, and it's going to open up. And when it's 0, it's going to look like this, where it touches just at one spot, but it just has 1 x-intercept. And then if it's negative, if your discriminant is negative, and your a value is positive, then it's going to look like this, where it's opening up, but it does not touch. It doesn't touch the x-axis at all. And so those are your possibilities, and you need to do that on the first page of your test, so as you're working through this. Now I can go back. 81, that's my discriminant. Let's put a little color to that. This is my discriminant. This is the value that we found. Discriminant, its value. And so we're just swapping them out. And then A, we said was 2. So this is 2. And now I'm going to just plug this in. Negative 11, I'm going to simplify it a little bit. Negative 11 plus, and the square root of 81 is 9 over 4. And then over here, negative 11 minus 9 over 4. And so it's the let's see here. This is my positive value, and down here, this is my negative value. And so that's what gives us the 2 numbers, is there's one plus and there's one negative. This would give me negative 2 over 4, and that if you do that division, that's negative 0.5. And this one, negative 20 over 4, and that would give us negative 5. And so those 2 values are my x values. And so now I can plug those into my x-intercepts. Negative 0.5, comma 0. They're points, so make sure you write them as an ordered pair in parentheses. Negative 0.5, comma 0, and negative 5, comma 0. And then I can graph those. Remember, they're on the x-axis. So I've got over here 1, 2. Let's erase that. 1, 2, 3, 4, 5, and there is 1 of my x-intercepts. And then just over here, negative 0.5, that's just negative 1/2, is right here, is the other one. And again, well, it looks right. There's that same distance here and that same distance there. That's what we're looking for. And now we can finish graphing this. This is just a sketch, but having these points helps us to kind of connect. These go up like this, kind of text up there, and then it's just going to continue with that same trajectory. And then over here, same idea, continues on up. And so that's kind of what this parabola looks like. Now, finally, it asks about the end behavior. As x approaches negative infinity is just a way of saying what happens on the left of this graph. Y does what? Well, as I move, let's use blue. As I move to the left, y is going up. So how do I write that? Y approaches positive infinity. But as y approaches, as x approaches positive infinity, what's happening? Y is doing what? Oh, well, if I go to the right, what's y doing? Oh, well, it's also going up. And again, how do we write that? Positive infinity. So with parabolas, it's either going to be both positive or both negative. So if I had a graph like this, then it would say, as x approaches negative infinity, what's y doing? Well, as we go to the left, it's going down. And so that would be y approaches negative infinity. And what happens on the right? As x approaches positive infinity, that's on the right. What's happening? Well, y is also going down. And so that would also be negative infinity. So they're either on a parabola, it's either going to both be positive infinity or both be negative infinity. This was something a lot of students missed on Unit 5. That's what I've got for you guys. You're gonna get your tests back if you haven't got your test back already. The substitute is gonna hand those back to you. So help him out as she calls out your name, whereas he calls out your name. He or she, I don't know, but help him out, and then you got this. I will see you here in a little bit. Hopefully sooner rather than later. It depends on how my dentist appointment goes. Thanks, guys. Work hard.